with our first four pitchers tonight, and they are all from CRI's Cohort 1. So Ian Hamilton of Atlas Energy Systems will be talking about his technology. Atlas is developing a technology that will generate electricity with no moving parts, and I will give it to him if he comes up here. There you go.
Thank you, Adria. Good evening, everyone. Thanks for being here. My name is Ian Hamilton. I'm CEO of Atlas Energy Systems. We are turning heat to electricity directly with no moving parts. So some of you might know that actually the waste heat to power market is incredibly large, with over 72% of all energy consumed being lost as waste heat. However, this number and these other markets do not even account for wasted or unused heat, of which the petroleum industry has one of the largest examples. You see, the oil and gas industry actually flares over 150 billion cubic meters of natural gas every year in the form of flare gas. This burns at over 2,000 degrees C, and this generates over 185 gigawatts of power. This heat is currently being unused and is wasted, even though it could provide on-site power requirements for the oil and gas extraction sites. Now, many people have looked at this market and this application before, but almost exclusively using gas turbines, which require the gas to be cleaned, and they also require the expensive and frequent maintenance. There is, however, some limited use of thermoelectrics in this application, another heat to electricity technology, but these are expensive and incredibly inefficient at often less than 1%. Because of these factors, diesel generators are still currently the main form of power generation, while other heat to power production solutions have largely been unexplored. Atlas is developing plasma thermionic energy converters, a heat-to-power solution that is distinctly different than thermoelectrics. The technology uses high-grade waste heat to boil off electrons from the surface of a metal. These electrons traverse a small gap where they collected on the other side of the electrode, and they can be used to do work generating power and electricity. The plasma Atlas is using allows for larger electrode spacings on the order of a millimeter instead of micrometers that is necessary with graphene or diamond-based technologies that you might be familiar with. However, the main difference is that the adsorbed liquid cesium is actually part of the emitter, and it creates a self-healing and robust effect. For this technology, Atlas has one patent allowed, actually as of last week, after 4 years of pending, and we have many more in the works through our research and development process. These thermionics represent a method of robust, maintenance-free electricity generation that could use existing flare gas to combustion to replace diesel generators at oil and gas extraction sites and provide on-site power for them. Atlas's business model is essentially that of an OEM, where we manufacture individual devices for combustion and product development partners. They will then lease these systems and sell the electricity generated, similar to current diesel generator business models. Now, just as an example, if Shell were to use flare gas thermionic energy converters to replace their diesel generators at their 35,000 sites around the world, they would eliminate almost a half a gigaton of CO2 emissions, and they could save over $6 billion on diesel fuel. This equipment, this doesn't even take into account their ability to power more equipment and create a more efficient site, or their ability to produce more oil, which if you want to learn more about that, you can come ask me about it. Now, Atlas is starting with flare gas to power, but these thermionics have much more applications than just waste heat. We would like to expand to the overall waste heat power generation markets, and then expand to concentrated solar and even advanced nuclear reactors. We currently have our thermionic nuclear reactor design, which has no moving parts, currently pending under the ARPA-E Open 2018 program. In order to develop this technology, we're partnering with machinists and manufacturing specialists at Argonne to build prototypes. We're working with researchers and development to develop processes that could lower operating temperatures, and even working with them on advanced manufacturing techniques such as metal 3D printing that would drastically reduce device costs even further. We are developing these plasma thermionic energy converters, and they are the first time they're ever going to be commercialized, even though the base technology is over 100 years old. As for our progress so far, we've demonstrated proof of concept of our nuclear technology at Argonne. We've built out our own office and manufacturing space in Romeoville, Illinois. We've identified some of our first customers that were actually the ones that contacted us about this flare gas application space. And we've, most importantly, grown from just me, by myself about a year ago, to 3 of us currently, all with master's degrees in nuclear engineering. And we've also put together an extensive advisory board that includes the former Deputy Undersecretary of the Department of Energy. For our next steps, we actually need your help, and we are looking for a $2 million seed round in funding for personnel and technology development that will allow us to build demonstration units and take us through pre-sales of essentially 50 kilowatt generators to sell to the oil and gas industry. We are looking for partners and investors with experience in energy technology, and especially in the oil and gas space. And this funding will allow us to develop the technology and grow our business, stepping up our application ladder from waste heat power to concentrated solar and the final goal of advanced nuclear reactors. And with that, I'd like to thank you for your time, and we'll be at our booth for questions if anyone has them.